Alright guys, this is unit number 8, lesson number 7, and today we're going to talk more about the zero product law and how we could solve quadratics with it. And I was told by people that my videos are a little dry and boring, so I thought I'd start this one off with an awesome joke. So, what do you call an alligator in a vest? Well, you think about that, because I'm not going to tell you the answer until later in the video. So, let's get right into it. So, the zero product law basically, remember, says that if the product of something equals 0, then one of the factors or both of the factors must equal 0. And this really helps us learn how to solve higher order polynomials and not just linear equations. Now we can solve equations like this through the zero product law. Two things must be true though. We must be able to set the equation equal to 0, important, and it must be able to be factored. So let's do a little practice. This is some review from last lesson. You should be able to do this. So solve the following equations using factoring. And remember, we want to know what x could equal to make these true. So hit pause and see if you could do all three of these on your own. All right, let's see. For part A here, did you factor it correctly? So that is correct factoring because 7 minus 5 is 2 and 7 times negative 5 is negative 35. Then remember, take each factor and set it equal to 0 and then solve that really easy linear equation that we have. So there's one of our zeros or roots or solutions. All three of those are the same concept. Set that equal to 0 and there are our solutions. And again, remember, these are referred to as the solution set or the roots of the quadratic or the zeros of the quadratic. All of those are the same terms. All right, part B, that was a little harder factoring. Did you notice there was a GCF first? So that's what you should have factored. And then once you factor out the GCF, you could factor this trinomial in there again. So that's what we call the factoring completely. Now remember, this 3 doesn't have a variable, so you can't make this factor here equal to 0. But it doesn't matter as long as this equals 0 or this equals 0, our equation would be true. So again, we're only going to set those factors equal to 0. There's a root. There's our other root and our final solutions. If you notice that the x squared, that's going to tell you there's going to be 2 solutions. And we'll get into that a little later, but that's an indicator of that. And part C, this was a little harder. Now you could have done it several ways. You could have multiplied and then added together and then tried. But notice that we have this and this binomial being multiplied to the same thing. So you could use your distributive law, pull that out, and put these two in parentheses, and it looks something, where is it? It's over here. So you can see that x minus 3 is being multiplied to this and to that. So you put these in their own parentheses. Then you could combine like terms and add these together. And here they just got rid of the parentheses and they did some associative and commutative properties. And then finally they're going to add combine like terms in here, and then you don't really have to factor. So either way was fine. Now you'll set those factors equal to 0. There they are. This one a little harder, so you should know that if there's a number in front of the x, it's going to lead to, not always, I apologize. A lot of times it leads to a fraction. This time it didn't. And our final solution. All right, so that was review. Hopefully it went okay for you. And let's keep going. All right, so now we're going to see how this is going to help us with more on the graph. So let's remember why this is such a crucial skill in the terms of parabola. So James graphed this quadratic right over here using tables on his calculator and found below he can tell from the graph and the table that x minus 2 right there is one of the zeros. But he couldn't tell the other one because it falls in between. So you can see that you'd have to estimate this is going to be 1 point something, but you don't know. So just using the graph, you can't find that 0. So now solving it is going to help us out. So write down an equation that would allow us to solve for the 0. So what equation could we use to solve for this 0? Could you come up with it? Well, all you have to do is take this quadratic, and remember to solve it, we just set it equal to 0 because this is when y is 0. So you should have just had something like that. All right, now look, they're going to give us some hints here. So how does knowing that x minus 2 is a 0 help you factor this trinomial? And then go ahead and factor it. So you know that x minus 2 is one of the zeros. That should be able to help you when you factor. So hit pause and see if you could do, oh, I guess you don't factor it yet. I apologize. Factor it down here. I don't know. Do whatever. All right. Now, let's see how you did. So it's in here somewhere. Okay, here's the factored form. And the fact that this x minus 2 is a 0, you should be able to come up with this. If x minus 2 is a 0, then this x plus 2 must be a factor, because remember, that's where this comes from. So just think of the opposite, and you could write one of the factors knowing one of the zeros. So then once you know that x plus 2 is a factor, well then this has to be 3x, because x times 3x is 3x squared. And this has to be negative 5, because 2 times negative 5 is negative 10. So once you know one of the factors, it's really easy to find the other, and you don't have to do all that hard work for it. All right. And now solve the equation in part A using the factors to find the zeros. So go ahead and solve it and find the zeros now. All right, and you guys should be hitting pause and trying this on your own and not just watching my answers. So it's much better if you try it on your own, even if you're not sure. That way when you're watching it, you're already invested in it and you're not just copying down notes and not really learning anything. So here we go. I got to find where all the good stuff is. So I don't know. Oh, it's already factored, so I guess we just have to take these and set them equal to 0. And there we go. So you can see what happened is that this one is 1 2/3. That's why we couldn't average that. And you didn't have to do this one because we already knew that x minus 2 was a 0. So we just had to find that other one. So there we go. All right, let's keep moving on. Okay, we could even explore a higher order of polynomials. So something like x to the 3rd. Now that we know what we're doing, these are also called cubics. So here is a function. This is a cubic function. We want to find the zeros algebraically by factoring, so you guys should be able to come up with the zeros for this, or the roots, or the solutions for that. So hit pause and try that on your own. All right, how did you do? So were you able to factor it? Let's find it somewhere in here. There we go. Set that equal to 0. You should notice there's a GCF. We haven't ever factored anything with the 3rd, so just factor out that x. Hopefully in here you recognize that this is a dots difference of 2 squares, so we can easily factor that again. So there's factored form. That's not the zeros though. Now we have to find the solutions. And again, I know you guys want to skip this step here and instantly say this, but we need to show work. It takes a whole 5 seconds, so relax, stop whining. And don't forget, this one we can set equal to 0 right here, so we need to do that one also. And notice before I said how x squared had 2 solutions, well, x to the 3rd has 3 solutions. So there we go. Now can you use your calculator and put in the windows, these parameters right here. Whoa. Sorry about that, still getting used to the new laptop. So again, put these parameters into your calculator and graph it, and just sketch a graph to the best of your ability by hitting the graph button. So do that now, please. All right, did your graph come out looking something like this? And hopefully it did. And knowing the zeros, you can kind of estimate where it's going to hit, and then you just kind of draw it in between there. Okay. Now we're not going to do too much of this stuff. This is more of Algebra 2, but they're just giving you a little preview of how you can still do these here. All right, let's keep going. Okay, on this one here, we have this quadratic. Now, you let me know if you don't like all this partially erased stuff, but it's been hard to find these things, so I'm sick of looking where I erased everything, so I'm going to leave the boxes, that way I know where everything is. So hopefully you can deal with it. All right, so here is our quadratic. You need to find the zeros algebraically. That means you can't just plug it in your calculator and find it on the table. You actually have to go through the factoring. And the Regents exam will ask you to do this algebraically, so you have to. So hit pause and please do part A on your own. Okay, how did you do? Let's see. So we have this, set it equal to 0, first step. Factor it was the second step. Now you take your factors, set those equal to 0. Pretty easy for you now, hopefully. And there is our solutions. So again, remember how I told you it's very important to learn how to factor. It's going to come up. We're still going to do a lot more with this, so we want to make sure we get it down. All right, now we want you to write the quadratic in vertex form. So remember, that's completing the square and then coming up with the turning point. So hopefully you remember how to complete the square. So let's see how you do. So hit pause and give that a try. Okay, remember with completing the square that we want this to be a perfect square, and so to do that you just take this, divide it by 2, and square it. So if this was 16, we could do -4 and -4, and that would all work. So remember, those are the steps for it. So the 16 again came from taking half of the b, which is 4, and squaring it. And it's got to be negative. Yeah, what am I doing? All right, so that's where the 16 and -16 come from. Remember, you have to put the +16 first because you can't take the square root of a -16. Now that this is a perfect squared trinomial, you should be able to factor it into that squared binomial. Remember, -4 plus -4 is 8. -4 times -4 is 16. Then just combine like terms here. And now we should be able to find our vertex. Remember, this is the opposite one, so this is really going to shift it to the right 4. So that's +4. That's going to shift it down. So there is our turning point. All right, now let's take a look at part C here. What is true about the x-coordinates of the turning point compared to the zeros? So look at the x-coordinate of the turning point and then look at the solution. And do you notice anything about that? Well, it should make sense that you notice that the 4 is right in between the 3 and the 5. So the x-coordinate of the turning point, x equals 4, is midway between the two zeros, 3 and 5, and therefore it is the average of the two. And it would make sense if you think about what a quadratic is when you graph it. That turning point, I know that's pretty ugly, but deal with it. That turning point is the only point that doesn't have a pair. Every other point has an exact opposite pair when you go through the quadratic. So this turning point is where the axis symmetry is. It's right in the middle. So every other paired point, that turning point is going to be right in the middle of it. So hopefully that makes sense. So let's look at this other part, D. Let's get that ugly drawing out of there. Without using your calculator, sketch the graph of this quadratic on the axis below. So you should be able to use the vertex here and the zeros to sketch a graph. So go ahead and do that without looking at your calculator. All right, so let's see what it should look like. It should look like something like that. Okay, so find the turning point. Okay, so we got 3 and 5. The turning point is down here at 4, -1. And then just do your best to sketch that parabola. Put arrows, and try not to do what I do, where when I do it, these should never look straight. They're always kind of going off at an angle, no matter what. All right, let's move on here. And I believe this is our last question. So before we answer the question, did you think about the first joke I told you? What do you call an alligator in a vest? You ready for this? You call it an investigator. Get it? An investigator. So funny. Now, that's not my joke. I got that from Carly C. So if you see her around, tell her how funny she is. And we'll see if we want to keep doing some jokes in these. All right, now let's do this last part here. A quadratic function can be written in factored form like this. Which of the following would be the x-coordinate of the turning point? So could you figure out what the x-coordinate of the turning point would be for this quadratic? So hit pause and answer that now, please. All right, well, if you remember what we talked about, the turning point should be in between the roots. Well, first you should find the roots, or the zeros. So we should know that this one's going to be -3 and this one's going to be +7. So now you have to find what's in between those. If you're not good at that, remember we said it's the average, so just add them up, divide by 2, and you should have got 2, which is option 2. So there we go. All right, hopefully that went well for you guys, and we'll see you in class.